Okay, so now that we know how to write formulas and we know what's going on in the bonding because we do the Lewis stat structures, we're going to talk about naming compounds. So let's review some things. So an oxidation number has two parts. It has a charge and it has a number part. So the charge part of the oxidation number, what is it if you lose electrons? Well, you're losing a negative charge. So if you're losing a negative charge, that means you have more positive than negative. So you have a positive charge overall. So that's the opposite if you gain electrons. If you gain electrons, you have gained a negative charge, so your overall charge is negative. The number part of the oxidation number, if you recall, is how many electrons you have lost, gained, or shared. Okay, so there's two ways we can determine the oxidation number of an atom. The one way is we can look at how many valence electrons an atom has, and we can determine how many electrons it will lose, gain, or share to have 8. And then the other way is just to look at the periodic table. And remember, by looking at the periodic table, we're going to see what group it's in. And then remember that first column is +1, +2. Skipping across the middle section, we have +3, plus or minus 4, -3, -2, -1, and 0. So let's review how to write a formula. So when we write a formula, the positive ion always comes first. And those oxidation numbers then are going to switch places, and they're going to become subscripts for the other atom. And don't forget what a subscript is. It's just that little number at the bottom that tells us how many atoms there are. Okay, so here are our naming rules. So we're going to write the name of the positive ion. And remember that positive one came first. And so then we're going to write the name of the negative ion. And instead of just writing that whole thing down, we are going to take off the ending and we're going to put an IDE on it. So you may have heard this before, like you've heard of sodium chloride. Okay, so it's not sodium and chlorine, it's sodium chloride. Okay, so let's review that formula writing again. So you're going to need your periodic table for this. So you're going to need an oxidation number for aluminum, which is +3. Oxidation number for chlorine, which is -1. Okay, so to write our formula, we have the positive ion first, which was aluminum, Al, and then that -1 tells us that there's 1 aluminum. And then symbol for chlorine is Cl. And then that +3 here for aluminum tells us there's 3 chlorines. So the formula is AlCl3. Now to name it, we write down the name of the first one, which is just aluminum. And then for the second one, instead of just writing chlorine, we're going to change the ending. So it's chloride. Okay. So instead of chlorine, chloride. So aluminum chloride. That's it. So let's try another one. For magnesium, we look up the oxidation number. It's +2. Bromine, we look up the oxidation number. It is -1 again. So we write down the positive one, Mg. And this tells us there's 1 of those. Br, and then this tells us there's 2 of those. Okay, so our formula is MgBr2. Now for the name. So we write down the name of the first one, magnesium, and the name of the second one was bromine. So instead of bromine, we're going to have bromide. And it's that easy for the ionic compounds. Okay, you have some practice here. You're going to need your periodic table. Go ahead and try them. Okay, let's see how you did. So the oxidation number for lithium is 1. The oxidation number for oxygen is 2, negative 2. So when we write the formula, lithium has to come first, so Li. And then this 2 tells us there's 2 of them. And then we have O for oxygen. And then this 1 tells us there's 1. So for the name, you have lithium. And then O is kind of a tricky one. We know we need to change the ending to IDE, right? So instead of saying oxygen, we just do oxide. Okay. Okay, so calcium is +2, and phosphorus is -3. And calcium is Ca. And this 3 tells us there's 3 of them. And phosphorus is P. And this 2 tells us there's 2 of them. So we have calcium. And instead of saying phosphorus, we just shorten it and say phosphide. Okay, one more. Aluminum is +3. Oxygen is -2. So we have Al, 2, O, 3. So we have aluminum oxide again. Okay. So now that we have the hang of that, we want to introduce one more thing and then we're finished. So we have polyatomic ions, and I've briefly mentioned this earlier if you were paying attention, but a polyatomic ion is just a group of atoms that are bonded together that have a charge. So it's just kind of like they're hanging out, running around together, okay, instead of by themselves. And the 2 important things here. One is that these guys are going to act like a single ion when they form compounds, okay, so it's not really a big deal. Instead of having an oxygen that's going to switch, charges and going to combine, you're going to have one of these guys. And there's just one trick to writing these formulas, is that if there's more than one of them, you're going to use parentheses to show it. And the reason is because a lot of these polyatomic ions have numbers in them. And so when you're writing them, it can get a little confusing. So I'll show you what I mean. So we're just going to do 2 examples and then we're going to be done. So here we have aluminum. So aluminum is just an element, right? I know this because it ends, aluminum, but it ends in okay? So aluminum's oxidation number is +3. Nitrate ends in 8, so that's how I know it's going to be on this polyatomic ion chart. Okay, so I look it up right here. Nitrate is NO3 -1, okay? The -1 right there. Okay, so when we write this formula, you write Al like you would normally. It's the positive ion. This -1 tells us that's how many. Now, we're going to write NO3. So it has a number in it. Now, that's part of who he is. That's like his right leg. Okay, you cannot do anything with that number. You have to leave it with him. That's part of who he is, okay? But we do need to indicate that there's 3 of these guys. So if we were to write a 3 right here, okay, it would really look like there's 1 aluminum, 3 nitrogens, and 33 O's. Right? And so for this reason, we use parentheses around the polyatomic ion to indicate that there's really 1 aluminum and 3 nitrates. Okay? So that's the only trick here. So naming them. Naming them, you'll love it. It's super easy. It's even easier than anything else. You write down the name of them. So aluminum is aluminum, right? And then the NO3, you just write down the name of it. NO3 is nitrate, so you write aluminum nitrate. How easy is that? Okay, so let's try a harder one. So this one has ammonium sulfate. Now, ammonium is the only positive polyatomic ion on the whole thing up here. So ammonium is NH4 with a +1 charge. And sulfate is right here. It is SO4 with a -2 charge. So when we write these guys, okay, we're going to write 2 ammoniums. So I'm going to put that in parentheses. So I don't want it to look like I have 42 H's. I want it to look like they have 2 ammoniums. And then I have 1 sulfate, so I'm going to write SO4 like that. Okay. And then to name it, it's just ammonium sulfate. There's no ending to change or anything like that. So the polyatomics just can be a little trickier in writing the formulas, but the naming part is actually easier. So I hope that was easy.